Miles of tiles! We're going to be configuring some little shapes into the frame shown above, and those little shapes reminded me of my Cuisenaire rods. Introducing Cuisenaire rods. So I took them out. I got 10, 9, 8, 7, 6, 5, 4, and lonely 3. And we have 14, and we also have 12. And with these, we noticed we can also flip them around. So we have 5 and 7, 7 and 5. So here we have our Cuisenaire rods in the 12 and 14 position. We have a 10 and a 4, an 8 and a 6. So here we're just trying to fill in our northern position, right here. So our first position is the 10 and the 4. But they can also flip-flop to make another position. And they can't only flip-flop, but they can also flip-flop from bottom top. So that makes a third position, and then we have a fourth position because the top, which was once the bottom, can also flip-flop. Womp, womp, womp. So that's 4 different things that can fill that space. But there's also 3 other spaces around it. So when we look up here at this top line here, we know there's 4 positions that can go there. So it's sort of like 4 guys standing in a line. We have 8 plus 6, 6 plus 8, 10 plus 4, and 4 plus 10. So if we need to predict about how many people to put in the beginning of the line, if we have 4 people, we need to say that the groups in the beginning of the line go down, then we have 3, then we eventually get to 2, so when we get to 2, and then eventually we get to 1. And so when we're trying to calculate permutations, use 4 times 3, which is 12, and then 12 times 2, which is 24, and then 24 times 1. 24. Since we have a 14 there and a 14 there, that means 24 times 2, which is 48. And then we have basically 2 sides that we're solving for 1. So we have a 7 plus 5, a 5 plus 7, a 9 plus 3, or a 3 plus 9. And then we have what's up there. So we have a 48 again. And then 48 times 2 equals 96.